Consider the graph of the quadratic function f of x is equal to 2, and in brackets x plus 6 squared minus 9. So the first part, we have to state the coordinates of the vertex of the graph. Well, we can do that without even graphing this. This is the vertex form, and that can give us a lot of information. The two most important numbers here are these two right here. So the vertex in this case is going to be -6 and -9. Now, you may be wondering, why is it -6 when in the original equation it seems to be +6? Well, the general form of this equation is f of x is equal to x minus h squared plus k. Now, because of that minus sign right there, that's going to affect your sign, so it's almost like it's the opposite of whatever you see in the original equation. That's why it's going to be -6. This does not affect the y value though. As this is -9 in the equation, it's going to be -9 in the vertex. In B, you have to state the equation of the axis of symmetry of the graph. Well, the axis of symmetry is also equal to the x of the vertex. So in that case, x is equal to -6. That's your equation. So in C, does a function have a maximum or minimum value? State the value. Well, this part right here, which would be your A, that's going to tell you whether or not this is going to be a maximum or a minimum. This here is positive, so you'd end up with a parabola that's actually pointing upwards. That would mean we would have a minimum. What is the minimum? Well, that's actually going to be the y value of your vertex. So your minimum for this particular function is going to be -9. You have to state the domain and range of the function. Well, x can be everything. Okay, so x such that x is a member of the real numbers. However, of course, when it comes to the range, that's where we have an issue because we do have a minimum. We can't have a y of -10 or -15 or anything like that. It only can go down as low as -9. So we just have to let the viewer know what that is. So that's going to be y such that y is greater than or equal to -9, because y can be 5, it can be 4, it could be even -8, anything over and above -9. And of course y is also a member of the real numbers. So the next one, determine the y-intercept of the graph. Well, we know with y-intercepts that the x is going to be 0 when we have the y value. So all you need to do is replace all the x's in the equation with 0. So we're going to have y is equal to 2, and you're going to have 0 plus 6 squared. So I replace the x with a 0 minus 9. So what you have here, you're going to have 2, 0 plus 6, that's just 6 squared minus 9. And so working this one out, that's going to be about 72 minus 9, which is about 63. So your y-intercept in this case is going to be 0 and 63.